Picture this: spacecraft billions of kilometers away, sending a message through a laser beam so precise it's like hitting a bullseye from a moving car at the speed of light. That's exactly what NASA just achieved with its Psyche mission, communicating across an eye-popping 350 million kilometers, roughly 1.8 times the average distance between Earth and Mars. But here's where it gets controversial. This isn't just about bragging rights. It's a bold step toward revolutionizing how we connect with the cosmos. And some experts argue it could redefine our future on other planets. Ready to dive into the details? Let's go! NASA's Deep Space Optical Communications project has just proven that lasers can transmit data across the solar system without losing their signal. Imagine firing a laser from Earth to a spacecraft moving at breakneck speed, then catching its reply like a whisper from a distant star. That's the challenge the Psyche spacecraft, managed by the Jet Propulsion Laboratory, has mastered. Launched in 2023, this metal-obsessed probe is on a 6-year journey to study the metallic asteroid 16 Psyche, but its secret weapon is a laser transceiver. This gadget sends and receives data using light beams, a method far faster and more efficient than traditional radio waves. And yes, this is the 65th and final test of the technology, marking a major milestone in space communication. How does it work? Picture a 3-kilowatt laser beam fired from Earth's Table Mountain facility, acting like a lighthouse to guide Psyche's path. Once the spacecraft locks onto the signal, it bounces a reply back to Earth. But even at the speed of light, this exchange takes minutes to complete, given the mind-boggling distances involved. To catch Psyche's faint response, scientists at Caltech's Palomar Observatory use a giant telescope capable of spotting the tiniest glimmers of light across the solar system. The data is then decoded by a high-tech detector array, turning those faint flashes into usable information. Pretty cool, right? Optical communication isn't entirely new. NASA previously beamed a laser video of a cat chasing a dot from 19 million miles away in 2023. But scaling this up to 350 million kilometers? That's groundbreaking. Why does it matter? Current missions like Voyager 1 and 2 rely on radio waves, which are reliable but slow. Lasers, however, can transmit data at speeds comparable to your home broadband internet, a game-changer for future missions. For instance, imagine streaming a live video of astronauts playing golf on Mars in high definition, a feat that would have been impossible with older tech. Sean Duffy, NASA's acting administrator, put it best: technology unlocks discovery, and we're committed to testing the tools needed for the golden age of exploration. But here's the twist. Some critics argue that laser communication is still unproven in the harsh, unpredictable environment of deep space. What happens if cosmic dust or solar flares disrupt the signal? Will radio waves remain our backup plan forever? These are the questions that keep engineers up at night. And this is the part most people miss. The success of Psyche's laser tests doesn't just benefit Mars missions. It could also help us communicate with spacecraft exploring the outer planets, where radio signals take hours to arrive. So what's next? NASA hopes this tech will enable faster data transfers for human missions to Mars, where astronauts might soon send home ultra-detailed reports or even virtual reality tours of the red planet. But let's get real. Will we ever fully replace radio waves with lasers? Or is this just another gadget in our space toolbox? Drop your thoughts in the comments. We'd love to hear if you think laser communication is the future, or if radio will stick around for decades to come.